So welcome to Advanced Algorithms. In the first part, we'll just talk about some organizational bits. I'll go relatively quick, but I wanted to have this on record so that it's there to refer back to. The goals is to show you how the module is run and how it's assessed, and then the follow-up little unit will give a bit of an overview of what it is about. I'm Sebastian Witt. Wild is fine if you prefer. I'm occasionally sitting in my office up there. Best if you want if you need something, best is fire an email or use Campuswire for things that are specific to this module, especially if they're relevant to other students. I'll come back to that. We'll have Mohammed help us in the tutorials. We'll come back to what happens there. The most important piece of information is the module website. If you haven't run across it, that's where you find all key information. I'll try to make everything that can be on a public website onto this public website. I just find it myself so much more convenient not to have to log in every single time you look up some little bit. I feel this is also helpful. I didn't at all copy paste the slides. Other bits that we're going to use are Campuswire, which is a Q&A forum. I'll explain a bit more what this looks like, but you can already sign up. There's the join link is on the public website. The link and the pin is on Elias, but it's also here if you want to do that later. Slido you already saw what we use it for, and as a rough summary, as we're forced to do it like this, the final mark will come from the final assessment, whatever that is, and that's it. There's no way to do partial marks in an easy way, but you have to earn the admission to the exams via points in the exercise sheets and the mini seminar that I'll comment on later. We've seen Slido already, so you know what it feels like. I just want to motivate a bit why I'm using it. I feel it's a very helpful psychological little trick to activate people from time to time. Otherwise, it's easy to fall into the mode of watching TV, which is fine, but sometimes is not as effective for learning something as other modes of listening. It also gives me a little bit of feedback whether you're following along. That's helpful for both of us. You've seen what it looks like. That's polls, which is I push a question out to you and you get to answer, usually multiple choice, and you can answer a question. You can ask questions on the audience Q&A at any time in between. If it's hidden because there's a poll running, you can still switch the tabs. I hope it's intuitive enough. Let's skip this because we've done an intro question already. In all my lectures, there's always the question, how do you organize lectures in general? And many of you will have had the dubious pleasure of having to do studies during the pandemic, where everyone was forced to do some experiments with alternative modes of teaching. I've actually done my experiments with alternative modes of teaching well before then and concluded I don't like it. At least not pre-recorded videos and then flip teaching, where I send you off to watch videos and then we meet and discuss afterwards. I just couldn't get it to work. And that might be my fault, but I always felt it's very hard, also if I'm experiencing myself, to stay on track with the lecture if you're not forced to synchronize at specific times. So that's what we'll do. We'll have synchronous live lectures, but I give you the option to watch them from your couch at home if you feel that's helpful for focusing, or if you can't come for some reason. And if you can't make it at all, there's recordings which are not interactive, but at least you can still catch up what we've covered. And you can rewatch if your memory is fading. Now, if you want to do anything interactive, there needs to be something coming back from the audience to me. And the traditional way would be some students occasionally ask questions, and you're encouraged to do that whenever you feel that's helpful. My experience is only a very small subset of students do that for many reasons, and that's fine. So I'll always try to have other back channels. There's Slido for questions, which you can use during the lecture, and Campuswire later. And little polls in between just to keep you awake. I've covered most of this already. So we have lectures, and we'll have these Slido questions, and we have Campuswire. More on this. Keep referring to this. We'll come back to this. We'll also have some tutorials with exercise problems. Many of the topics that we'll cover only really get understood by doing it yourself, by proving things yourself, by designing algorithms yourself, and by doing reductions yourself. So there will be handy-in exercise sheets. This will only start after the mini seminar, which should be here too, together with the tutorials. Let's add it. The exam, of course, in the end is a requirement. And I'll do this experiment again of having a collaborative exam question gallery where you can collect possible exam questions. And the more work you do there up front, the more I promise to comment on those questions. And we'll see how that goes. My experience is if I tell you to do this now, nobody does, because you haven't learned that much in this module. So I'll reopen this a bit later in the term, try to raise enthusiasm for it when we get to it. Let's talk about assessment briefly. As I said, the actual points you get at the end come from the final exam. That's the only option you have, the only option we have. I'll announce soon whether it's written or oral. And the material that's covered in either of those forms of exams is everything that we cover in class, except maybe sometimes I feel I'm making comments that are useful if you want to go into researching this further, but are really a bit over the top. Then I'm sometimes marking them with not part of the exam. Anything else is covered. And also the tutorials and exercise sheets, because these are often complementing what we do in class. So they're part of the exam material. To be admitted for the exam, we decided to set the rules so you can skip up to 2 of the exercise sheets. Might be a lot because I'm planning to do them bi-weekly instead of weekly. But I'll let you know. And 50% of the available points, but the marking will be mostly rewarding genuine attempts, not only completely solved. And the last bit is a little extra thing we'll do over the next 2 weeks. That's the mini seminar on NP-completeness. So because the group is a bit diverse and you come from different backgrounds, much of the later parts of the module really don't make sense if you don't have a solid foundation in the classical complexity theory, NP-completeness. And I can, of course, run through this here, and I'll do that this week. But to make sure that you have a chance to grasp this, you'll have to do something from your end. And so what we'll do instead of lectures the next 2 weeks is a little mini seminar where you prepare in groups one topic from NP hardness and present it in 2 forms. So again, the goal is to make sure everyone's on the same page with respect to NP-completeness before we move on. And it's a master's module, so you're supposed to go towards the cutting edge of research. Now, we'll do this with a very old research paper, so cutting edge is not a literal term here, but it's still primary research literature. which is always a bit of a different type of reading. If you read textbooks, everything has been pre-digested a few times before it's presented in a way that the author thought at least is most useful. Primary research literature is often a bit more rough and concise. So it needs practice to read those, and that's one way to do it. And same as in the exercise classes, I want you to be able to write proofs in a way that is rigorous. And so that's another way to test that. So what you'll do concretely is make a written report of one NP hardness reduction. And we'll pick some classic examples where it's not incredibly hard to find material online where people already explain this. But the point of the whole mini seminar is that you put this in your own words and you dig through this one example very deep. So one deliverable is the written proof. And it should be the general construction plus a fully worked example for the two cases that you always have in NP hardness reductions, a yes instance and a no instance, just to make 100% sure you understood the construction. You'll have done some of this in a theoretical computer science module if you've done one, but hopefully not exactly the problems that are on the list. And I think it's a good refresher before we move on. The second bit, maybe the bit more fun part, try to make a nice explainer video out of this. So this first, the written report should be completely formal, mathematical language and formulas and all that. You're very welcome to use LaTeX for that. If you feel a different system is better, that's fine. The second part is a bit more conversational and is just supposed to make it easy to understand your construction. So in a way, your video could be a high-level introduction to your report, so that if someone wants to dig into the details of the proof, they can watch the video and get the gist of it, and then see the full details in the report. And so that these videos are not write-only documents, each group will also watch over the video and the report from 3 other groups and write a little report just summarizing how well it worked for them to understand the reduction. I'll send out some specific guidance. This will be very narrowly guided, so you don't have to write a lengthy essay how you liked it. It'll be specific guiding questions. But I think it would be a shame if you make nice videos and then nobody sees them apart from us. So the goal is to have this over roughly weeks 2 and 3. And my original idea was to pick the original and first and only paper where NP-completeness was introduced. I don't know if you know the story behind this. This was, when did he publish? I think it's 1973, 73. It's certainly early 70s, but don't quote me on the year. And also, I guess the results were known a bit before, and then it took a while to publish. Richard Karp published one paper that I have here in nice typewriter, where he invented the idea of NP-completeness and gave 21 NP-complete problems, where for most of them, he just lists very shortly, very briefly, the construction. And he doesn't even bother to spell out the correctness arguments, why the reduction works. So the goal would be to pick, these are 21 problems, but it's really just 20 reductions, because one of them is Boolean satisfiability, which is separately proven. That's the Cook-Levin theorem. If none of this makes any sense to you, by the way, it will after the end of tomorrow's lecture. I'll go over the basics of this at a crazy pace, but so that at least if you haven't heard anything about this before, you'll know your basic way around. So there's 20 reductions in there. If we stay at 120 people, that would be a bit big groups. If we are roughly of the size here, it might work out. If we don't cover all problems, that's also fine. But I think group sizes beyond 5 people is getting tricky. Yeah, I have a website prepared with more details on how this is going to run. But if you have specific questions now, let me know. There's one question also on Slido. No. You can see. It's part of this module. That's why I call it a mini seminar. It's not as much work. You're in the master seminar that also exists. You're usually reading full papers and maybe several of them and compare them, something like this. And you do it alone. So here we have 3 to 5 people working on it. And the part that you have to read from the paper technically might be something like just a single formula or so. Many of the reductions in here are really, really short. You'll probably have to read the definitions to understand them, but it's far less intense than the seminar modules. Other questions about the mini seminar for now? Okay, let me go back. There's one thing we haven't talked about, which is Campuswire, but okay, tutorials first, that as well. So formally, the mini seminar is part of the admissions for the exam. You'll do a few less of the exam exercise sheets. You'll do the mini seminar instead. And those two things together are the admission requirements. I hope it's not supposed to be a super overwhelming task. And the videos can also be low fidelity. So essentially have someone film with a smartphone while you write on a piece of paper is not a stupid idea for a theory thing. I've seen that done with pandemic time tutorials, and it was super effective. It doesn't need to be any flashy animations, although if you want, you're welcome to. After, should probably put this here somewhere. We'll start with this after the mini seminar. More traditional exercise problems on a sheet that you hand in a group, as most modules have it in some form. So that's what we'll do as well. I'll probably have the pleasure to present some solutions to you in some central exercise tutorial. But we'll have to find a room for that. So again, because we only start after the mini seminar, I'll delay the decision depending a bit on how big the audience still is. As I mentioned before, we'll be a bit more lenient on the marking because the intention of more lenient than in an exam, the intention is to get you working on problems. While we talk about exercises, I noticed there's a new thing around, and you noticed too. It's amazing fun to play with all sorts of, I mean, DeepSeek for these kind of problems, theory problems, is pretty useful. I wouldn't say it kind of solves anything without guidance, but it's useful as a research tool for sure, and for many other things. What it doesn't do is help you learn. Quite the opposite. And if you take a step back, why are you doing this? All of this, like your degree? Why are you studying here? Maybe there's many reasons, but hopefully one good one will be that you take skills out of this that help you in your career, set you apart from maybe other people who haven't invested the same amount of time. All of this is kind of compromised if you let some AI do the work for you, specifically for these exercise problems. They're designed for you to help you acquire skills. So don't cheat yourself by taking away the thinking. And I'm not even saying that we try to catch you cheating. That's not my point. If you're smart about doing it, you won't be caught because you let AI make suggestions and you just rewrite it in some human form. I'm never going to find out, but you're also never going to get the skills that you wanted if you don't bang your head against the problems for a while. I know it's very tempting. It's pretty hard, especially if time pressure ramps up. But try to remind yourself of just not doing it. Is similar to, that's why I put this quote here. It's a bit of a jokey quote, of course, but the point of doing exercise in a physical sense is also not to be 10 kilometers away. If you run in circles, for sure not. It's about what you get out of the exercise. And if you let a robot do the same thing, or if you drive by car, it's not the same, right? Okay, enough about that. Just to be very clear, it's acceptable to do preparatory research. So replace Wikipedia in a sense. Use it as a point to jump to the right place to then read more. That's fine. I'm also fine if you use it for proofreading your writing. It's always nice to read well-formulated text. Don't use it to generate whole parts of your submission without proper acknowledgement, citation, and so on. Don't use it to make something that you took from somewhere else sound different so that you're not caught. It's obviously ethically problematic. And also avoid letting it do all the thinking for you. Okay, I should have prepared this one. Let's do this quickly because I think this is a key question. So you can think about this while I'm setting up Slido. What I'm looking for here is a criterion self-reported from students that had the strongest correlation with them also cheating on assessments. So there was a specific thing, interestingly striking how much it stood out, that correlated well with also cheating. Now it's called correlation, not causation, but I think it's still an insightful thing. So have a guess. What do you think? Of all, I mean, it could be personality traits, it could be habits, it could be, God, demographics, gender, whatever. It could have been. Thankfully, that is not what it was. It's a good point that cheating can become a habit. But the point here was there's something that correlated with having the habit. Not going to class, not studying. Work perfection is an interesting one, yeah. Yeah, language, I mean, barriers of all sorts don't help. I'm reusing the poll from different lectures, so maybe someone remembers. The right answer is among the options. Pressure in general is also is an interesting one. That would have been my guess. The more desperate you are, the more you're going to cheat. But that wasn't quite true. Yeah, so the answer is among there, and it's procrastination. Students that tended to procrastinate, to not get things done in time, and not necessarily because of pressure or outer things or really like hardship cases. It was the habit of not planning and managing your time well enough that constantly led to being behind and then I mean, procrastinating is the process of spending your time unwisely, but it also means that you have trouble reserving the time for the important things, right? That's the flip side of it, of course. And it's interesting that it correlated so well because it kind of seems to be the source, the root of time problems later on, and many other correlating things, maybe pressure and desperation and all that kind of flow from it. Okay, I'm not gonna be able to analyze more. This is just something. The source is given in a video where the context is explained a bit more. I found this useful to push out just as a nudge. Get your time management right. It's another obvious one. Not telling you any news, maybe. Okay, Campuswire. I would say it's closest to Reddit before it became apparently not a nice place anymore. You can ask questions, they pop up at the top, and you can post answers, and the answers are ranked by how many people upvote them. You can reply to answers, so it has the same kind of structure. The difference in Campuswire is it's a bit more specific to the setting of a lecture, of a university lecture. So you can only sign up with your university email by default, for example. In case you're having trouble, try to use something with the Uni Marburg domain. The other feature is you can ask questions anonymously. If you don't want to expose yourself in front of the whole class, that's okay. And you can ask anonymously, also answer. But the idea is really that the whole group also tries to help out others, because the best way to learn is to teach others. It has two features that we use. The class feed is what I was speaking about. That's the Reddit-like feature. There's also chat rooms that are just a little less structured. And maybe for instantaneous things are sometimes useful. The class feed should be the standard Q&A place. If you have a question that relates to the content of the material or also organizational things that are not super, super urgent, the best is to put a question out on Campuswire, because then everyone can see it. And I can answer it once if it's organizational, and you can try answer it for others if it's content-based. So any of these types of questions. If you found an answer helpful, then upvote for it. That will influence the ranking. And it also has a credit system, so you get some, you can climb up the ranks by being active. There's an option to ask a question privately just to instructors if you feel it's spoiling some assessment. That's the way to go. Most other things I think is fine to have public and anonymously if you want. Right. Just to be explicit, I'm trying to push Campuswire. If you send me an email and I feel it's something that should go on Campuswire, I'll reply to your email, but I'll just say Campuswire. Okay, I'm never going to reply with an actual useful answer. But if you put it on Campuswire, if it's urgent, I usually have it quick on the phone and see it on the day. But I might not respond if it's a content question to give other students a chance to answer. The goal is to be fair, because everyone gets the same answers, which is different if you come up after class. Then depending on how much time we have, I think it's preferable to do it on Campuswire. It helps you to learn if you can answer for someone else, and it's more inclusive if everyone has a way to express themselves, I think. As I said, I'll redirect you to the class feed on Campuswire with wherever that's the most appropriate place. I'll hold up answering a little bit, and I'll promise if someone answers the question for me and does a good job, I'll eventually put in endorsed or forget what the term was on Campuswire. But there's a way to mark it as, okay, instructor has said this is actually right. Yeah, something like that, but it's a different term, and you can assign it to several answers. So it's not like Stack Overflow. Yeah, see how you get on. First sign up, and then we'll have a play a bit, and maybe we can discuss tomorrow again if something doesn't work or if you have questions about it. There's also Elias, the official university online learning platform. I'll mostly use it for anything that cannot go to a non-university server, which is all your personal data, especially anything relating to marks. If you sign up on Campuswire with some fake name, I guess that's all right. I don't really need you to be identifiable there. Elias is different. That's where anything official happens, which also means I'm going to use Elias not that much, especially announcements. The only thing you can do is send out emails, but then if you signed up for the module late, you cannot see the past emails as far as I know. And whereas Campuswire, if you join later, you can still go through all the old posts and read up on what happened.